Hey everyone, and welcome to This Explainer. Today, we're unpacking a really fascinating framework known as the foundations of combinatorial enumeration. Now, I know that sounds like a mouthful, but what we're really looking at today are the surprisingly simple, incredibly elegant mathematical secrets behind how we count possibilities in our universe. If you've ever wanted to instantly grasp the sheer scale of choices in front of you, well, you're in exactly the right place.
Okay, let's dive right into this. It really all begins with a seemingly impossible question. How do we count without actually counting? Just think about that for a second. If you're faced with thousands or literally millions of possible outcomes for a specific scenario, how can we possibly calculate those massive totals without manually pointing at and counting every single item one by one? Well, mathematicians have figured out a brilliant way to shortcut the system.
Section 1. The Basics of Counting. So the whole philosophy here is about abstraction. It's about taking these complex, messy, real-world tasks and transforming them into beautifully simple mathematical variables that we can easily manipulate. To build this foundation, we have to strip everything down to an absolute basic premise. Imagine you have a single task in front of you, and that task can be completed in a specific number of ways. We're going to call that number m. So one task equals m ways. Now imagine a completely different, completely separate task, and this second task can be done in a different number of ways. We'll call that one n. It doesn't matter if these tasks are picking out an outfit for the day or choosing a travel route across the country, we've completely isolated them into two simple variables, m and n. Section 2. The Rule of Sum. That brings us to our first major tool in the combinatorial toolkit, which deals directly with those isolated tasks. The rule of sum states, if one task can be done in m ways, and another in n ways, the total equals m plus n. Basically, this is the mathematics of or. It applies when you're going to do one task or the other, but definitely not both. You simply take the options from your first bucket, your m, and add them straight to the options in your second bucket, your n. Breaking down the anatomy of this formula, you can really see why this works so flawlessly. Task 1 stands entirely alone with its m ways. Task 2 stands entirely alone with its n ways. They don't interact, they don't cross over at all. This is strictly an either-or scenario. And because they remain completely separate entities, when we want to know the total possibilities of doing either one, they just pool together into a simple, straightforward sum, m plus n. But what happens when our tasks don't stand alone? What happens when our choices actually start interacting with each other? Let's move on and see how this builds. Section 3. The Rule of Product. The rule of product tells us if one task can be done in m ways and another in n ways, the total equals m times n. Notice the subtle but incredibly powerful difference here. We aren't doing one task or the other anymore. We're doing one task and another task. When we sequence tasks together like this, we no longer add. We absolutely must multiply m times n. When you put these two concepts side by side, the contrast is actually pretty wild. On the one hand, we have the either-or addition of the rule of sum, m plus n. It's flat, it's steady, it's predictable. But on the other hand, we have the and also compounding multiplication of the rule of product, m times n. In this scenario, every single choice you make for the first task branches out into a whole new set of choices for the second task. Notice how both rules start with the exact same phrasing. If one task can be done in m ways and another in n ways. The absolutely crucial takeaway here is that these exact same starting conditions dynamically scale into drastically different totals just by tweaking a single mathematical operator. Changing a simple plus sign to a times sign represents a fundamental shift in how reality branches out in front of us. Section 4. Understanding the factorial. Sometimes counting requires an escalating continuous chain reaction. And this brings us to factorials. A factorial is an n followed by an exclamation point, and it equals n times n minus 1 all the way down to 1. In mathematics, that isn't just punctuation to show excitement, though honestly it is a pretty exciting concept. That exclamation point is a literal, explicit command to multiply a number by every positive integer less than itself. Think of it like walking down a descending mathematical staircase. Step 1. You start with your total number of initial choices, your n. Step 2. You make a choice, which removes an option, so you multiply your starting number by the remaining options, n minus 1. Step 3. You just keep making choices, cascading down step by step until you hit exactly one final option. 5 times 4 times 3 times 2 times 1.
N factorial is fundamentally a chain reaction of multiplication. And this brilliantly illustrates how the factorial acts as the ultimate mathematical shortcut. It automatically does the heavy lifting of the rule of product over and over and over again without you having to manually write out every single branching path. It effortlessly captures the sheer volume of ways you can arrange a set of distinct items.
Just n and an exclamation point. It looks so small, so compact, but because it relies on the compounding multiplication we learned from the rule of product, this little formula scales up explosively fast. To put that into perspective, if you have just 10 items to arrange, 10 factorial is over 3.6 million different possible combinations. 3.6 million? That is the hidden, mind-blowing power locked inside that exclamation point.
Section 5. The foundation of enumeration.
All right, it's time to view these three concepts not just as abstract math equations, but as the unbreakable logical foundation of all counting. We start with the rule of sum, which is just simple addition for isolated choices. Then we step up to the rule of product, which is multiplication for sequences of choices. And finally, the factorial, the cascading, ultimate expression of multiplied descending choices. Together, this is an escalating shortcut that entirely bypasses the need to manually count the world around us.
Which brings us to our final thought. These are the foundational rules that literally govern the complexities of combinations and permutations in everything from high-level computer science to planning out your daily schedule. So I'll leave you with this. Knowing these three incredibly powerful rules, what universe of possibilities are you going to calculate next? Thank you so much for exploring this with me today. Keep asking great questions, and I'll catch you on the next explainer.